Hello everybody and welcome back. Thanks for tuning in to another episode here. My name is Dominic and I'm the host of the Android Factory. In case you missed it in the last episode, we went ahead and implemented a little bit of a shimmer layout for these individual cells here that we see on the emulator. It turned out pretty good, to be honest. I'm pretty happy with how it came out, so I'll link a card in the top right in case you missed it. And today we're going to talk about architecture a little bit. So if you are brand new, please consider subscribing so you don't miss out. And smash that like button to help me out here as we approach 2,000. Thank you guys so much for the support. It's been a lot of fun lately. Okay, so we have a main activity here, and that's about it. There really is no other architecture. It just exists inside of onCreate. We make a network call, we handle the response, and then we display that data on screen. We're not even handling like errors or anything along those lines. We're really just submitting an empty list if the network call fails. So there is a lot to clean up here, but first and foremost, we can kind of start to build out a little bit of an architecture and eventually get into the MVI or the Redux pattern that we're going to be using here today or for this application. So inside of our main activity here, we have two dependencies, right? The product service and the product mapper. The service is pretty straightforward. It just has our retrofit service here to kind of annotate the endpoint that we're hitting. And then a product mapper here, if you missed it, it's just a way to convert from a network object to a domain object. It's just basically a helper function along the way. So there are two dependencies here, and we're going to first uplift this into the MVVM pattern, because I think people are most familiar with that, and then it'll be a good segue into the MVI Redux-like pattern. So I've created this main activity view model. We've annotated it with @HiltViewModel. We've annotated the constructor with @inject. And we have the products repository injected into the constructor of this view model. Wonderful. Inside of here, we have our mutable live data that's private, and then our public, just regular live data. And this list of products is the data that we're actually working with to display something on screen here that we see in the emulator. We have one simple function here, the refresh products. We have the entire function wrapped in the viewModelScope.launch to actually make the network call here via the repository, and then whatever we get back, we just post to the live data. So it should be a pretty common pattern. Quickly taking a look at the repository here. Again, we're leveraging Hilt to get all of our dependencies involved. So we are annotating the constructor with @injectConstructor, and then here are our two dependencies, the service and the mapper, that the activity had, that we just discussed a minute ago. We have one suspend function in here called fetchAllProducts, returns a list of products, and as you would imagine, we are making the network call. We are $.letting on the body there, so this block will run if it is a successful API call. And then for all of the network products, which is the list of products, we just call map, and we use our product mapper to actually build the list of domain product objects. And this gets tossed out to our function here in the view model, and again, that just gets set. I haven't updated any of the error handling. You see here we're still submitting an empty list in the event that the body is null, i.e. the network call failed for some reason. So we still have a bunch to clean up here, but what this does afford us is a few things. We can create an instance of this view model here inside of our main activity. We can remove our two dependencies because that's no longer something this activity needs. And then very simply here we can say viewModel.the products live data. We're going to observe it. This is going to be our products. We'll simply take this, copy that over there, set data just products. And then we can tell viewModel to refresh the products. Sure, I guess we'll handle this. Copy this little bit of error handling over. For if something is empty, we just display a toast, and now we can completely remove that. Okay, so now our main activity is a little bit better designed, right? It's still doing the same thing. We set up all of our epoxy stuff. We go ahead and observe our live data, and then we tell our view model to go ahead and refresh the data. Don't worry about this function down here. This is just the on-click listeners for all the different UI elements. So imagine this thing is in here, and realistically, this is all the activity is, just this onCreate function. Our variables, our class level variables have now kind of cleaned up, so that's nice. I'm going to go ahead and rerun it here to just show you that everything should be working as expected. And we're coming back to life here, and look at that. We have all of our data again. We're making the network call. We seemingly everything is working exactly as it was before. So that's great. This is a pretty traditional MVVM approach. It's a very simple one, right? We're just making one network call. There's just one channel of data coming to us. But the idea of, observing a live data, right? This activity, this view layer has no idea how this thing gets updated. It just knows whenever it does, I need to display that list inside of our controller, and then the controller takes care of, and Epoxy takes care of displaying everything for us, right? Okay, so that makes a lot of sense. However, now I mentioned we're going to talk about the MVI and the Redux-like pattern because that is what we're going to use for this application. So stay with me here as I talk about this hypothetically for a moment, right? We have one activity here. Eventually this is going to become its own fragment, and we're going to go ahead and have like a bottom nav and all that kind of stuff, so it'll be great. But essentially right now we have one screen that handles a list of these products, right? Now, it's very likely that we're going to build out another screen somewhere else in the app that also needs a list of products. In the current MVVM pattern, what I've found is that it is clean. It does help to provide the separation of concerns that you want. However, we would at the very least need to contain this products repository again, right? Something to get all of the different products that we have. And if we had all the products on this screen and we navigated the user to another screen that needed all of the products and then all of the something else, right, that it also needed, and then it combined that data, it would be a little weird to kind of pass that list of products into the other class, right? Like that's not something that we would normally want to do. In the single activity architecture with the shared view model, you could have a view model that's scoped to the activity. And if this was scoped to the activity, you would then have the live data of the list of products available to all of the fragments within that activity. And that's kind of nice, right? But that is helpful in some cases, but it isn't always necessarily like the cleanest. It isn't always the most obvious that that's available to you at the fragment level. It kind of just starts to fall apart a little bit, especially if you need more than just a list of products, right? What if you need 5, 7, 15 pieces of information shared throughout your application? It would be very difficult and very annoying to do so in the MVVM pattern. Now, this is where the MVI or the Redux pattern starts to really come into play here. Because the idea of the Redux pattern is to basically hold a central store that has all of the actual data within it, and then everyone who needs information can basically ask the store for information. You can kind of think of it like a lightweight database that's where the data is available to everyone in the app and anyone who wants to subscribe to it. And then with the power of flow or live data and lifecycle aware components, we can actually go ahead and build out a pretty reactive application which just starts to flow really nicely at scale. Okay, so I was looking around for some graphics to kind of help you guys with this because it might be a little weird to just hear me talk about it. But this is, I guess, the smallest or the most bare bone version of it, right? The idea is you end up generating some kind of a state. That state has a way to be translated into a view. And then while the view is on screen, while the user has something to look at and interact with, they perform actions that then impact the state and modify the state. By modifying the state, that then generates, a new state, and then that gets rendered as a view, right? So a pretty good example of this in the future is going to be when somebody clicks this little icon up here, we're going to be modifying the state saying, hey, this product has been favorited, and then the state will get regenerated, and it will say all of these products except this one are not favorited, so therefore go ahead and redraw yourself, right? Same idea with adding things to a cart, or if we add quantity, or whatever the case is, right? There are certain actions the user can provide to modify the state, and then our UI, our view layer, reacts to those changes and displays something accordingly. So enough talk, let's get into it a little bit here. I'm going to go ahead and create another package. If you guys made it through that little spiel, thank you so much for following with me. I didn't know the best way to convey all of that. But we could create a package there called Redux, and then we're going to create a class here called a store. This store is going to be a general store without it actually sounding like some kind of brick and mortar location. The store is going to be, what I mean by general, is going to be of type T, meaning this could be a store of string, this could be a store of list of products, this could be a store of my favorite data class, etc., right? So it just provides us that flexibility, internal here, we're going to have a similar pattern that we have here inside of our activity view model, with the mutable version of something private, and then the public version of it being the non-mutable version. Okay, so we're going to start with something like this, right? We're going to have the underscore state flow be the mutable state flow. A state flow requires a parameter here, so we are going to have to pass in the initial state here that the store is created with. Then we have our public-facing state flow that is of just type state flow of t, and we again just point to the mutable thing. So we do have kind of a similar pattern here. We get to leverage some benefits of state flow along with just flow in general, as far as the different flow operators and all that kind of stuff, so that we can manipulate the data and work with it however we need it. I'm going to go ahead and create something here called a mutex. We'll dive into it when we declare these next few functions, but it's basically a way for us to just lock the store when reading or writing, so that we don't run into any, race conditions or any sort of collisions or any kind of issues that we just want to avoid. Okay, so now we need a way to update the store whenever something happens, right? When a network call comes back, when the user interacts with a button and now they favorite something or they add something to the cart, or whatever the case is, however they interact or however the system interacts, we need a way to actually update this store. Okay, so let's break this down a little bit because it might be a little confusing. We have a suspend function named update. That should be pretty straightforward. Then we have one parameter to this function. It's named update block, but it is of type basically lambda. This is an annotation, or this is a syntax here to describe a lambda. And what this means is that this is a lambda whose only argument is going to be t, and then the return type of that lambda is also going to be t. And the idea here is we can call update block with the current state flow value. So basically at any moment in time when this code will run, the update block will send out to the lambda the current snapshot of the store and say, here you go, this is what exists in the store right now, but we're going to need a store back, right? It's not a store, it's actually a t, right? But we're going to need something back that we gave to you. And the point of that is, obviously we need to be able to save the state here, which is what we do on the second line, but it gives the update block here the current situation, the current status, and asks here, do whatever you want to do, but give me back the same thing, right? So this allows that block to modify something. This allows that block to remove something, add something, reconnect different dots here and there, whatever it needs to do. We don't care, as this, in this class, we don't actually care what happens. We just have agreed upon, I'm giving you t, and I need basically a new t back. It doesn't have to be the exact same t, it just needs to be a t. And as we start to hopefully not just work in generics, it'll start to make a little bit more sense. The reason we need this as a suspending function is because the mutex.withLock is a suspending function. Without getting too far into it, I know I mentioned it before, but it's basically a way to prevent collisions. If two things are trying to access the store at the same time, one of them will access this update block or the read block we're about to create, and it will lock the store. So basically there's no way for people to be manipulating the store while someone else is working with it. So it's just a really good way to bulletproof yourself from any multi-threading kind of thing, which happens all the time in networking operations and that kind of stuff. So as I mentioned, we're going to create another function here, suspend function read. We're going to go with read block that will take in a t and return unit. So we will have another lambda that accepts t. That's going to be our state here. And then we don't need anything back, right? Because the job of the read block is not to actually return anything to us. It's just, as a screen boots up, I need to read from the store because I need to see if we have all this data in there or whatever the case is. And then, we can go from there. So very easily we can just call read block here with our stateflow.value. Wonderful. So now we've created a scaffolding. We've created a very simple way, a very simple store to actually maintain the current state, lock that state when we need, basically what's called a critical section, right? And both of these, either updating or reading, are critical sections, right? We don't want things changing while we're trying to do those operations. So we basically wrap those functions with the mutex.withLock, and everything is just handled for us. Really, really, really good stuff. Now comes the fun part for actually creating the T, right? And I'm going to go with application state as the name. Again, it doesn't matter. It could be my favorite data class, whatever the case is. But now this is going to be a data class that represents the state of the application. The store is kind of the plumbing to allow everyone to access the state, work with the state, manipulate the state, do so in a thread-safe manner, all that wonderful stuff, really, really good. But this is the class that's going to actually encapsulate all of our information and really, really start to describe at any moment in time what our application state is, right? Are there products in there or not? How many items are favorited? How many items are in the cart? Whatever else we decide to build out, all of that is going to be encapsulated in the state within the store inside this app. So we are going to create a val here. We're just going to call it, I guess, products, sure. And this is going to be a list of products here, and this will start as an empty list. This whole data class here will grow over time, but this is all that we have either in the app or on screen at the moment, so that's really all we need to care about for the time being. Okay, so the last little bit that we need to do here, now that we have our state here that we can constantly modify, and we have our scaffolding for the store, is we need a way to actually have this in a centralized manner so that it's the same store across all of our different screens, UIs, whatever the case is. It's wonderful that we started with Hilt from the very beginning because we can actually go ahead and leverage the singleton idea of Hilt or any dependency injection library to ensure that we're working with the same store from screen to screen here. So I'm going to create another object here called the application state module. I'm going to go ahead and just copy the annotations that we had here for the network one because they are going to be the same. I went ahead and just renamed this file because it was kind of bothering me, but now we basically have a way to simply create and get the same store of application state from anywhere that actually needs it, right? So we can inject that into the activity, we can inject it into a view model, whatever we need, we have the same store. So let's go ahead and actually start using this. We'll bounce over to the main activity view model. We are going to still need certain components from that MVVM because we do want the, the separation of concerns. So we're going to need that products repository, but we're also going to need our store here, which is going to be the store of application state. Once we kind of put that type in, we then, get the little annotations in the corner to show us where that is being used. So we do know that things are kind of hooked up properly. We are also going to make this a public one so that we have access to it outside of just the view model because we are going to have to access the flow of the store in a different layer. However, what that does afford us is the ability to remove this. Okay, so now here we have a list of products, and instead of publishing that to a live data that we had before, we are going to simply call store.update. This is going to give us the application state, so I'll go ahead and rename that for us. And we need to return another instance of the application state, right? We could do something like this that would satisfy our compiler. However, this is just asking for the store and returning that exact same store back. So there's no changes to it. However, what we're going to do is say copy, and we will say the products equal the products there. And perfect. This is exactly what we need to do. Again, inside of our view model, we fetch the products or refresh them. Here we are actually fetching them. And again, there's not all the error handling. We'll kind of figure that out later. But at this point, we can then update our store, right? So there's nothing internal here anymore to this view model that this activity is listening for or anything. Updating the store is very simple, right? The application state, half the reason we use the data class, not only for equals and hash code, is because they have this handy dandy copy function, and then you can specify what you want to change, right? So if there are 15 items in this store and there's only one thing that needs to change, we can make use of that copy functionality to just update the stuff that we cared about, right? Or that we were responsible for. And out here in the activity, yep, we obviously don't have this. So instead, we can say viewModel.store.stateflow. And then here we can simply call actually as live data, which is helpful, and then observe and then we have this, and everything else works exactly the same. So I'm just going to go ahead and copy this guy here. And now we have some other error here that's saying that if there's a type mismatch, we're required to have the list of products, but it's found in application state. And that's because this here, right, if we Control-Shift-P, that is a state flow of application state. And then we turn that into live data and observe that. So that's going to give us back the entire state. So if we wanted to, we could rename this here to say state, and then this could be, state.products or something like that. But I don't like that as much. What we can actually do is we can leverage flow operator to actually help us out here. And what we can do is we can say map and then simply pass in it.products. And so this here, as we saw right here, that is a state flow of application state. And if we look after this map operator on the flow, we can see that now, oops, sorry, I moved my cursor, that now it's a flow of a list of products. So now this is really powerful because we have the entire state available to us, but then we can boil it down to what we actually care about, right? We don't need the entire state. If the entire state had 15 other objects inside of it or other data points, we don't need all of that information. We only want the products for this screen. Now, the most important part too is being able to call distinct until changed right here and then calling .as live data. Now, what this will do, specifically distinct until change, is not update this flow if something else updates in the store and we didn't care for it, right? If there were, again, I'm going back to just 15 other things here, maybe let's update something here to say val username is a string, and it'll start as an empty string, and then at some point it will get updated to DOM after 10 seconds inside the application or something like that, right? In order to update that inside of our store, we would need to call update, and we would need to generate a new state of the store, of the application state. That would then get posted to our flow, and if we didn't have something like distinct until changed or .map and just caring about the products, we would receive an update to our collection or our live data idea here when we didn't actually care for one, when nothing to us changed, right? Because the only thing that changed was that the username changed from empty string to DOM. Nothing about the actual products here changed, but yet we would still receive an update because there has been a state flow change. As I mentioned earlier up here, the state flow, right? These flow operators down here, the map combined with distinct until changed, and then there's going to be a way to kind of translate a handful of different things that we care about if we care about multiple different data points. All of this stuff is extremely powerful and extremely helpful because we don't get additional updates that we didn't care for. We could very simply go ahead and rerun this application, and things should just operate exactly how they have been. Coming back up here, we do have this little snack bar that says fail to fetch, but that's actually not a problem. That's just because when we observe our application state in the very beginning, it is set to an empty list. So of course it's going to satisfy that if statement there. I'm going to remove this because we don't need it anymore. But that's fine because this isn't really proper error handling anyway. So you know what, we can just probably remove that as well for now. Let's go ahead and just rerun things here so that it looks fine. But we did see that everything is basically working exactly the same. We have a little bit of that shimmer layout to kind of show the loading. And then all of our data here came back as normal, and the whole application works the same. This might be a little bit of a longer episode. I do apologize. Apologize if it was a little tough to follow, but hopefully you'll start to see the idea of Redux and really how powerful it is, because now this store here that we've created as a singleton is accessible anywhere. And that affords us a lot of flexibility when it comes time to build out fun UIs, manage state, manipulate state. All that kind of stuff is going to be a lot easier in the Redux-like pattern, which is hopefully a lot more fun, and it'll be a little bit more interesting once we start building out favoriting and building out the cart and all that kind of stuff. You'll see how it comes together and how it would otherwise be extremely annoying. So if you made it this far in the video, I really, really do appreciate you. You're definitely like top 0.01% of viewers, so thank you so, so much. I hope you did learn something from this process. If anything is confusing, please reach out in the comments. I'll do my best to kind of answer everything and clarify things for you here. But this is a pretty good foundation for what we're trying to do here. We'll obviously beef it up with a little bit more, not just an empty list, but a better way to describe how things are in progress, or if they failed, if they've succeeded. We don't really have that encapsulated inside of the store here, and that will just kind of enhance our error handling. Things still are the same though, right? We have a view model, we have a repository. That repository still has dependencies between the service and the mapper and all that kind of stuff. So it's not completely brand new, it's just a different way of thinking. And I think it'll really start to click as we start to add in some of those more user interactions, and you'll start to be able to really see how everything comes together. But again, thank you so much. I'm very excited to continue with this. Redux is pretty powerful, especially with a lot of these flow operators and distinct until change and all that good stuff. It really, really, really is beautiful to work with inside of current Android, so I'm excited to bring that to you. Thanks for watching. I'll catch you guys in the next one.